Record this. Okay, so welcome everybody to the Cloud Native CI/CD using GitOps event. Our Ádám Sándor, who is the Cloud Native architect in CS, will be presenting today and talking about these magical tools. Just a short reminder, the session is 1 hour, and I would like to ask everybody to be muted unless you want to speak. You are of course free to talk when you have any questions at any time. Yeah, enjoy the session. Please, Ádám.
Yeah, welcome everyone. Very happy to see you all here. So this session is going to be about CI/CD and GitOps, and the format is pretty free-form Q&A. I would kick things off with laying down the basic terms and so everybody understands what we're talking about, that we're all on the same page. Anytime, feel free to interrupt, ask questions, drop some topic. We can talk about some challenges you are facing right now, questions you're pondering. Anything goes in there that is related to the topic, and I'm very happy to have a discussion here and share as much experience and stuff that I can. All right, let's get started. I have some slides here to help me with explaining things. Just a sec. So first of all, first of all, I need to figure out how do I share my screen. Yes, I managed to do that. There. I hope you all see my screen right now. If
Yes.
not, then shout. Okay, and so let's just get into first, what do we mean by CI/CD? The slides are, by the way, from a conference talk of mine that has this very related, but is a bit different. So I'm not going to go through exactly the slides. Just use them a bit here as helpers. Also, I have Draw.io prepared here to draw boxes and arrows. That's always fun. So what do we mean by CI/CD? It's already very interesting that these two terms have coalesced into one little package, CI/CD. While actually the two things mean something mean quite different things. CI has arisen from the need to automatically test our code and produce some kind of artifact that we can later deploy. So unit testing is the word that is the concept that is most familiar to everyone. Basically, we run our code here on this. I could zoom in on this slide. This is the beginning of this process. Yeah, is this visible? Check out unit test, compile, build image. Like, you know what? I'll just go with Draw.io, and that will be closer to what I'm actually wanting to say. So the first problem we have when we want to get our we have an application, we have source code, right? And we want to get this application. I'm gonna zoom in so we all can see this. We want to get this application into production in front of our users. And for this, we have to do certain things. We want to make sure this application is well tested. And so this is production, and there are users using our application in production, right? This is we have to get from here to here. This is our goal. So first of all, we need to do as much as possible to verify that our source code actually works and is not full of bugs. So that's the best tool we have for that is unit testing. I wrote JUnit because I'm a Java guy, but yeah, let's just write unit testing. And basically we can do all kinds of static code quality checks and many things. So let's say we can also say this is like Q&A on the source code, the way you're testing. And in the end, we produce some kind of artifact. And the whole idea of CI was this to make sure we produce this artifact, and I'll call it an image because of course these days we talk about Docker images, so the artifacts, we don't have to talk about generic concept of artifacts. We create an image, and this is going to be our image here. And the whole idea of CI is to create this image with as few bugs as possible and to provide real fast feedback to developers, because what we have learned in software development is that the faster we get the feedback to people, the faster, the lowest the cost is to fixing the problems. If the IDE of the developer screams already while he or she is typing, then that's the cheapest way to fix a problem. If it blows up in production, that's the most expensive way to fix the problem. So this is our, what's a nice title here, there. So CI goes, and because in the whole picture of CI/CD, it's sometimes we are a bit unclear on what do we mean by CI and what do we mean by CD. I think the best way to separate the two is to say CI goes all the way until an artifact is produced. After this is done, the image is created, there is no more unit testing happening. It is also very important that we don't do this process again and again once we merge to other branches and we want to deploy to other environments. So I will actually move production down here so I have a little bit more space. And what happens to this image after we have created it? Basically, the problem is with this kind of testing, we can't create any kind of image. We can't do any kind of testing. So what we will need to do is to now, before we would deploy to production, unless we go all the way to testing in production, we would deploy this to some kind of testing environment. So, oh, okay, the font has changed. What size was this? This was 12. Let's go back to 12. I like the 12-point font. And so we say we deploy to test. So we will have, before production, we will have a testing environment where this image will be running together with other applications in a realistic environment. And we can actually test in a production-like environment. And after we've done that, we can deploy to production. And of course, we might still screw up because this process is still not full fail-safe, but at least we can say we have done as much as we could to prevent any major problems. So, and this is the continuous delivery part of our whole full CI/CD process. And of course, we have been deploying to test environments before we had continuous delivery. So that's not the full picture. It's only if we look at the process, this is how we can separate CI from CD. But the important part of continuous delivery is that this whole flow happens automatically. That doesn't mean that there aren't some kind of manual tests, like for example here, or manual checks happening. Let's say a QA person is checking whether the application works here before letting it go to production, that's fine. But the actual deployment to this environment will happen in exactly the same way as it will happen to production. This is really important. And it will happen in a fully automated way. And this way, we can, when this whole process is as automated as possible, maybe only with only manual QA and compliance approvals are allowed. Basically, these are the only two types of manual steps that, that are, that are allowed to happen in this process. So here we can say, what the hell, come on. So let's say release management, compliance, whatever we call it. If you're not in a regulated environment, you're a lucky person and this whole second part can go away. But if you are, then this needs to happen. And so all these deployments happen automatically. This happens automatically. And that means this whole process can go very quickly, which leads to smaller chunks of functionality that we can release. Because releasing many smaller pieces of functionality is much less risky, and we get something to the users much faster than if we do huge bundles of like half-yearly releases, or even 2 weekly releases become very big bundles of all kinds of features that are then very risky to be deployed together. If something fails, it all has to be rolled back together. So so the goal of CI/CD is to make everything as smooth as possible, so we don't have to worry about a production deployment, but we can do it easily. We can do it in an automated and repeatable way, and that way we can do it more often, releasing smaller chunks, leading to less risk and making everybody happy, especially our users. And basically the current technology landscape mostly revolves around Docker and Kubernetes, and both of these technologies help a lot with this process. On one hand, because Docker can standardize our artifact, it's always a Docker image. It doesn't matter what kind of technology, if it's a Python app, if it's a Node.js app, if it's a Java application, it always becomes a Docker image, which is very important because that means we can have this beautiful technology called Kubernetes that then can deploy and run all our applications, because it doesn't have to worry about what kind of application it is. It can just run whatever is packaged as a Docker container. So this is why Docker and Kubernetes are so significant in the area of continuous of CI/CD. Are there any questions, remarks up to this point? My last thing that I want to talk about is GitOps, and then we can just go totally freeform. We also have a little demo to show this process using Jenkins X. We had some technical difficulties with that, so my colleague Rafal is working in the background to get it back up and running. But yeah, so that's also something I can show if there is interest. Any questions so far? Are you guys with me?
Yes, really good, really clear. I like the fact you use Draw.io to explain that. It's much more engaging than looking at slides. So thanks for that.
Oh, cool. Thank you. Thank you. I was a bit wondering which will be better, so that's
no,
very
it
good
was,
feedback.
I know
Thanks,
it's kind of, it's like flying without safety net, but it was much better. I think I'll pinch that idea. Nice one.
Cool, cool. Thank you. I also feel better about it than just pointing at things at slides. It feels a bit more dynamic. Great. Okay, so how does so GitOps is a kind of hot thing right now, and I'd like to explain the reasons why. So what are the problems in this pipeline, especially the CD part? So when we work with Kubernetes, I think I'll make this one a bit larger so we have space here, as we'll need to get a bit more into how things work. I'll start calling this app1, not just image. Yeah, we can have an app2 also. And this is Kubernetes production. And we have our two applications running on Kubernetes. And what does, in Kubernetes terms, the fact that we deploy these applications, it means that we put a declarative piece of configuration into the API server of Kubernetes, which is practically a key value, like a document database where we store, well, we can say YAML files. Of course, it's not really YAML files. It's like a data structure made up of lists and maps, but we can just say that we put our YAML file into the Kubernetes API server. Let me try to move this to the top there. So this is the Kubernetes API. And actually to make app 1 and 2 run here, we have to, inside the Kubernetes API server, we have to define two deployments. Name is app1, and then we have another deployment. Name is app2, and so on. And here we, of course, define the image of this app. So the image is actually app1, and this is the image, or maybe let's say app1 v1. We're running out of space. And this would be, let's say, image app2 v3. So we just deploy the first version of our application of app1 and app2 has been running. Now, the challenge here is that Kubernetes is great. Once we insert this data into the API server, Kubernetes will just magically make it happen, whatever we specified here. And it's really beautiful because this is a declarative configuration that we don't have to care about how we are changing. So once we say to Kubernetes, for app1, we want to go from v1 to v5, or we want to insert another application, Kubernetes will just make it happen. So that part is great, it's easy, it works. The tricky part is that where do we store this configuration that goes here? How do we manage it? How do we make sure that we know who changed it and for what reason it was changed? So it drifts a bit towards the compliance. So the things I'll be talking about are less important for a startup getting their first application into production, and much more important for a larger company where maybe it's regulated, but even if it's not, there are many more employees, possibly malicious people, etc., doing things. And then just the features that the Kubernetes API provides are not necessarily enough. So what happens, and I will, with the deployment to test, I'll just move it to the left now. Actually, everything can happen exactly the same way with the deployment to test as with the deployment to production, but I'll of course not draw everything twice. So let's move the compliance guy here. And to solve the problem of managing who, when, and how, and why did make a change to the Kubernetes API, and also to possibly segregate the development team from deploying to production. So this is a developer. And of course, we trust our developers, but in a large organization, it does matter how many people actually have access to something. Just the number of people makes security much easier or harder. So if we have, let's say, 50 people in operations and 2,000 developers, giving developers access to production or not can make a huge difference in our security profile, even regardless of compliance and regulatory requirements saying that there should be like a 4 eyes principle approval process and these kind of things. So my first encounter with GitOps was actually solving this problem, that installing a CI tool like Jenkins. I'll use Jenkins as an example. Actually, if we get around to the demo, it will be Jenkins X, which is very, very, very different, but it doesn't matter. Any kind of CI tool is basically a pipeline execution engine. So we can implement this physically in a Jenkins how should I draw this in the Jenkins, just by making this one pipeline inside Jenkins, this CI pipeline. So we would have our inside Jenkins can execute pipelines, right? And so we would have the CI pipeline inside Jenkins. Then we would have the deploy to test pipeline inside Jenkins, and we would have the deploy to production pipeline inside Jenkins. Now the problem here is that if we don't want to give developers access to deploy to production, plus we want auditing on who did what to production, then putting everything into this one Jenkins means we will be heavily relying on the Jenkins' security features to segregate these things and who has access to which pipelines and so on. And plus we still only get audit in the sense of like Jenkins pipeline executions, which is not a very information rich thing. However, here comes the GitOps part. What we can do is leverage the fact that Kubernetes has this declarative configuration file format. We can move the compliance guy again away from here, and we can put a Git repo here that is not a repo of the application itself, but it is a repo that is related to the environment. So this will be a Git repo describing the whole production environment. So this is a Git repo for production. Of course, in an enterprise environment, you would have on the same cluster many environments, and in that case, this Git repo would maybe correspond to one namespace, for example. Yeah, there. And inside this Git, this production Git, we would actually store the exact same stuff as goes into the Kubernetes API server. And the guardian of this repo can be operations, release management, whoever is like compliance approved person. And from a developer, and whenever this repo changes, we would update the applications inside Kubernetes. So we would, well, I'm just gonna use the same arrows. So this would be the actually deploy to production. Like, and then I'll start calling this sync to production. So when we now in this new setup, when we say we deploy to production, we are actually writing or making commits to this Git repo. Let's say we want to upgrade application 1. We have built a new image. We go through this pipeline. We build a new image using this CI pipeline. Then let's say we somehow deploy to test. And when we want to deploy to production, we execute, or let's say first way of implementing this is somebody actually goes to this production Git repo and edits this value to app1 v2, which will kick off the sync to production pipeline, which might be again a pipeline inside the CI tool, which will execute because this Git repo has changed and will sync everything in this Git repo to the Kubernetes API. And this is doable because of the declarative nature of Kubernetes, because we don't have, and the declarative means that we don't have to care what changed in this Git repo. Because if we would have to now write a script in this pipeline that actually figures out what has changed compared to the previous commit, then we would be screwed. That's not possible, or it's like prohibitively expensive. However, we can just, with Kubernetes, we can just iterate over all our YAML files. Yeah, so here it's each of these is actually a YAML file. So it's like app1.yaml, and which has which has a deployment inside it, but it's really a YAML file here, app2.yaml, and we can just iterate over all the YAML files and sync them to the cluster. And with this, every time we want to change the cluster, we can have a pull request created, let's say by the development team. The development team can create a pull request against the production environment with a full description of why and what they're changing. And the operations, release management, whoever, can look at that pull request and merge it into the master branch of this production repo. And then the sync process kicks in and syncs it to the cluster. This is the most basic implementation of GitOps that we can do, and then we can do many variations and go more advanced on this. But this is the basic GitOps idea, to sync a Git repo to the cluster. And this can also be done with like Terraform, for example. Instead of the Terraform can be used to, instead of like deploying Kubernetes applications on Kubernetes, it can be used to manage manage infrastructure like clusters and other cloud resources, because Terraform again is declarative. So whenever we would change something in the Terraform files, we sync it to our environment. And actually, in a way, with Terraform or CloudFormation, it's even more natural because you always have those files in a Git repo, and then you have to sync them. So that's kind of, mostly people are actually doing that, and we just call it infrastructure as code. But with Kubernetes, with application deployment, it's kind of less natural to do this. But nevertheless, it's still really useful, especially when we have to like satisfy compliance requirements. Are there any questions? I can still go into a bit more elaborate ways how to do GitOps, but I would maybe stop here when we just did the basics and ask for some questions. How clear was this?
I've got I don't know if it's in scope of this presentation, but one of the thoughts I have, like, you know, the devil in the detail and things like somebody wants to do a kind of blue-green release, or they want to do, you know, the little canary and see if things going. Is that kind of automation all included in this, or is somebody pulling levers somewhere to kind of make this happen?
Huh. Yeah, that's a very good question. How does canary, or, well, blue-green maybe you can still do with GitOps, like actually like maybe having twice the deployments in your Git repo, and then like doing the switch by actually making a Git commit. I think that's okay, but canary is a really good example where the limitations of GitOps become evident, because basically in canary you very dynamically want to be changing the percentages of what goes to each application. So if this was a canary release, let's say we remove app2 from the picture temporarily, and say we have app1 v1 running on the cluster now, and we want to deploy app1 v2, and we want to do this with a canary deployment. So that would mean we have to create a new deployment called app1, maybe app1 canary, I'll just call it C, and it will have version v2. And now you can use Istio or some other mechanism to divide the traffic between the old and the new version, right? You would want to monitor the error rates or some way to determine, or maybe just do some testing, or just monitor the your inbox of emails, whether users are complaining. Somehow you would measure whether you're happy with your new deployment. And you have to then start increasing the traffic on v2 and decreasing the traffic on v1. And this is definitely not feasible with making commits to this Git repo, or it is kind of feasible, depends on how fast is this process for you. Let's say if you do it in only 2 steps, like you go to 50% and then 100%, and this goes over the course of a full day, you might just do that through the Git repo. You might do commits to the Git repo. In that case, you kind of have a record of, okay, this manager has approved the increase of traffic to 75%, and you actually have a record of that because the Git repo actually contained the Istio configuration of how much traffic goes where. However, if you want to do this dynamically, let's say you want to hook up using Flagger, you want to monitor the error rates of the application and automatically increase the traffic on it, then you will need a separate mechanism outside of your GitOps workflow to do that. For example, Flagger. So you might have Flagger does exactly that. You would have Prometheus doing the monitoring, and then Flagger being hooked up to Prometheus. Come on, yes.
Well, that's good. I've not seen Flagger before. That's interesting.
I'm actually doing a Udemy course on canary deployments with Istio and Flagger right now. So I'm no expert on it either, but I have seen on demos what it can do.
And what it does. You didn't pay me to ask that question, right? Would it be the same as well with things like because and the reason I ask, it's just good to know, like, what's the good scope for this, and then what happens outside, rather than trying to make one process do everything. I guess it's the same for things like if you're using feature flags or something like that, it's just how to flip those. Would that be in the process, or would it be outside? I'm not sure.
Yeah, actually the answer is as usually it depends, right? So I think it depends how dynamic do you want to make things. I have heard and seen people do feature flags saying, no, we want totally dynamic, we want this UI for feature flags where I can go and I can swap a feature flag anytime, and I can change some percentages of what type of users go to get to see what feature. And this is happening all the time, and we are doing ABC types of tests at the same moment, and it's all super dynamic now. This use case is not a good idea for GitOps. However, I've also seen companies go like, no, we don't, every flip of a feature flag is technically a change to production, and we have to have like this change process because we are a regulated company, and we can't forego the change process just because we have feature flags now. So feature flags should be in Git, and every change to the feature flags should happen through the Git repo. So there is both ways are valid, and it really depends on whether commits to a Git repo are too heavyweight for your process. Usually for the basic deployment, they are good because you don't deploy that often. I mean, if every 5 minutes you deploy still a Git commit is not such a huge deal. But if you deploy, like if you do something more often than that in a more dynamic way, then it becomes a hassle to do that through Git and useless. Yes, sorry, there was somebody trying to speak, sorry.
Yeah, I was just wondering that maybe it's also possible to have the configuration of Flagger, Istio, and maybe even Prometheus that corresponds to app 1. You could also have that dynamic configuration inside of the, well, next to the, in the same Git repo, basically.
Oh, absolutely, absolutely, and you should. So like, so it's like the virtual service can be here for Istio, and there can be then the like 20%, 80% configuration here. But that's what I'm explaining, that like if you want to be changing this percentage, this 20-80% with Flagger, right, in a very dynamic way based on the latest Prometheus metrics, then this 20-80% you don't want to have in your Git repo, because that would mean Flagger would have to go and create pull requests against the Git repo that then somebody has to merge to be actually changing the percentage of traffic. So it really, but anything that you are running on Kubernetes, you can have in the Git repo, and actually you should. So for example, you should have another Git repo for also cluster generic things like that. I'm having Flagger. So like this could be the cluster repo that configures cluster services, like yeah, you would have like maybe a Prometheus.yaml and a just deploying Prometheus and Flagger and Istio, right? So these would be the cluster services that that you can also keep in Git, but and then sync to the cluster. So this would be a sync to cluster. And the cluster itself could be created by Terraform from another Git repo again. So basically the idea of GitOps is like keep everything in Git. And one important thing about GitOps is not just keeping everything in Git, but anything that changes in Git, you immediately sync to the target environment. So there are no more steps. This process here is very, very simple. That's very important, because if this process, that's like kind of the difference between infrastructure as code and GitOps. Of course, both of these terms are vague and whatever, but I like to explain it this way because infrastructure as code is the older term. And many companies who do infrastructure and code, yes, they keep everything in Git, but then once you change Git, there is still a heavyweight process with all kinds of maybe manual steps and button clicks and whatever to actually make whatever is in Git happen to the real environment. While with in a GitOps setup, especially since this term was kind of invented for Kubernetes, even though the same principle can be applied elsewhere. In GitOps, when this changes, the Git repo changes, it should immediately be synced to the cluster. There is no more in-between stuff happening. And while I'm at this, I would explain one more aspect of GitOps, is that you should only be changing your environment through the Git repo. It's kind of a no-brainer, right? Because if I can both change the environment through this Git repo, but I can also come and do kubectl something, edit something straight on the cluster, then of course the cluster will not be in sync with whatever is in my Git repo. But these things can happen. So an important aspect of GitOps is also to monitor any kind of configuration drift. And now we are syncing this Git repo to the cluster using a Jenkins pipeline in this picture right now. And with the Jenkins pipeline, there is not much chance of like actually monitoring whether the cluster is still in sync with the production with the Git repo. Also, it's pretty hard to determine whether services have deployed successfully. So there are actually tools now that that do this syncing, so you don't have to. You can get rid of this pipeline and have this sync process handled by Flux or Argo CD. So these tools both are Kubernetes specific, so you can only use them if you are deploying it. So no Terraform or anything like that. But with Flux or Argo CD, these are two different tools. Now, just to be clear on that, they are specialized for syncing the Git repo to the cluster, issuing alerts if the cluster digresses from the Git repo state. Also adding Argo CD as security features on like what kind of objects can I even put into this Git repo. Let's say if I want to put a cluster role binding, that might not fly, and some other nice features in there. So we're actually right now working on a blog post about comparing Flux, Argo CD, and Jenkins X. But I didn't write Jenkins X here because Jenkins X's scope is much bigger than just this, so it's kind of a special tool. So I'm putting it into brackets here. But it also does this amongst many other things. Yeah, I'm stopping here for any more questions. I have more things to say, so if no questions, I can go on. But just want to give you guys the space. Okay, if there are no questions, I hope that it's because everybody understands everything and not because you're completely lost. So what did I want to talk about? Oh yeah, one interesting one upside and one downside of GitOps. Oops, okay, I might try to do this with just this bar here. So a very nice thing about GitOps, what I really like about it, and now I will pull up my slides because it will be better to explain this. Yes, and Rafa just wrote me that the demo is ready too. So yeah, I will just wrap this up real quick, and we will still have a short time for an actual showing this process with Jenkins X. So at the X here. I would also like to leave question time so we can, but you guys didn't have any in the moment ago, so maybe just jump into the demo. But this is the if we visualize GitOps in this way, like it's on this this slide, I'll try to make it a bit bigger. So in this slide we have the CI pipeline up here and the deployment pipeline down here, doing the syncing of this Git repo to the cluster. And actually, it's pretty. It's okay. I can show it on this one. We don't need to jump to anything. So basically, there is this line here, and I really like this line here. Is the separation between whatever a development team's responsibilities are and whatever the operations team's responsibilities are, including like compliance and stuff. Right, so there is a very clear divider line that, or it runs somewhere in the middle of this Git repo. So development team can issue pull requests against this GitOps repository, and compliance or operations or release management can then merge those pull requests. And this is really great because and what happens behind this repo can be implemented in different ways, and it doesn't really matter how it's all implementation details from then on. So it actually helps you to use also different tools for implementing this part than So you no longer have this constraint that, oh, the CI process is in Jenkins, so now we need to use Jenkins to deploy the cluster. You can, through this Git repo kind of makes a nice split in your architecture, where whatever is on the left side of the Git repo can be different technology than whatever is on the right side, and can be managed by different people. And it's actually a really nice way to implement kind of a nice DevOps workflow in an environment where you need to have this separation of concerns. So that's really good, and I really like that about GitOps. The downside of GitOps is that because this is a Git repo and application changes happen frequently, you actually might not want, even just going here and changing V2 to V3 is a tedious thing to do manually. So you might want to be creating this pull request to this repo automatically here, let's say from the pipeline in Jenkins. And that means interacting with Git programmatically. That means doing a clone, editing a file, making a commit, making a push, possibly having a conflict, all those things. Yeah, Git is basically built for manual editing and not for programmatic access. The programmatic access can be done, but it's definitely not pretty, and yeah, and it's a bit of a hassle to implement. So that's for a downside of GitOps. Okay, I'll stop speaking. Are there any questions right now, or shall we jump into the demo? Silence will mean demo. All right. I hear a screaming silence for demo. Something's blinking here. Oh, there is a chat. Oh, okay. Demo, I wonder how rollbacks works. Oh yeah, okay, yeah, rollbacks. Yes, I just really quickly explain that because that's the simplest part in GitOps. So basically, when you do a rollback in GitOps, you, oops, more chat. Yes, Thomas Rice, just another commit, exactly. You just revert your commit in the Git repo. All your previous states of your environment are at this point in Git, and you can just go back to any previous state by just reverting to some previous state in the Git history. So that's how rollbacks work with GitOps. Does it answer the question, Steve?
Yes, it does. Thank you very much. Sorry for derailing you.
No. But I want this to be more of a Q&A. Actually, I talked way more than I expected. So that's the whole point of this, that you guys can just go and then we can have a discussion. But if there are no more questions, then we can jump into a quick demo. I hope the time 8 minutes is not sure if it's gonna be enough, but we can try. Okay, Rafal, I'm going to hand. Do I need to hand something over to you? How does this work? Can you share your screen, Rafal?
So let me see how I can do it. Here it is.
I'm not. Yeah. Okay. Great.
Can you see my screen?
Yes.
Yes.
Okay, thanks. So yeah, so I prepared something like on a short notice here. So just hooking up with what Adam was just saying. So the way Jenkins X works, so it creates for me like a few repositories, right? To actually map the environments for me. So I have this Git repo, which represents the staging environment. Can you see my screen? Maybe
Yeah.
Looks okay. So it was during the Jenkins X installation. So Jenkins X itself provisions, it creates this repo for me, given the right credentials for it. So here I have, inside this repo, I have the description of what is running in this environment, in this staging environment. So here, at this file, for example, I have this single app here, and I have version 003, right? So I could compare with another repo. So this one is the production one, also created by JenkinsX. And here I have version 002, right? So in staging, I have version 3, and production, I have version 2. So yeah, and just following the same like workflow. So ideally, I would just like go to this repo and would create a pull request. So we can try to do this and watch JenkinsX running the pipelines to see what happens. So
the way JenkinsX implements all these pipelines to both the CI pipeline and the deployment pipelines using Tecton. So it's JenkinsX has nothing to do with Jenkins.
So we're gonna open that file that we just saw. So this is my production repository, right? So I'm on my machine and I'm just gonna upgrade here to 3, right? And yeah, that's a change. So I'm gonna create a branch, promote my app. So yeah, I'm running on that branch, and I'm gonna commit this, promote my app to v003. Oh, sorry, typo there, but it's all right. Let's push these two. So I'm gonna push this branch, and here I'm gonna have a link to the pull request, right? So that's the workflow. So let's say I am a developer, I just created a request to deploy, right? But in JenkinsX terms, that means like I created a pull request, right? So if I click to that link, so that's the link to create a pull request. And let's say, please merge these to deploy my app. And I create a pull request.
Can we see the changes in the files to see what this pull request is changing?
Yes. So in the files changed. So that was the only file that I changed. So that means I'm changing this application here. So it is here as a Helm chart, and I just like upgrading the version of the chart. Right. So and now it is a pull request. So let's see if I can see the pull requests here. So here it is, my pull request page. So one interesting feature of JenkinsX is that it implements this thing called GitOps, which has like a bot user talking to us and running some commands for us, right? So here it is. So the bot supposedly is running like a few things here, a few jobs, and we can probably see here on Jenkins UI, JenkinsX UI.
Yeah, we didn't really have time to like go into how JenkinsX works. It's basically a very opinionated tool on how to set up a cloud native CI/CD setup. Completely similar to what's in the picture that I drew, but it does like all the things, like it provisions tools like Vault and creates Git repos and does this whole GitOps workflow, every piece of it, which means it might be pretty hard to fit into a current ecosystem of tools that you might already have. However, if you're starting from scratch, or you want just a nice demo setup to play around with GitOps, then JenkinsX is a really, really great tool because it just does all the right things around the GitOps workflow.
True. So here in the UI, you can see the difference between the two environments, right? This is staging and production. So we're gonna go back to the PR page and gonna prove that PR. So even though it's still running here, so we could wait for it, but let's try to approve. Yeah. So I think the bot still needs to run all the checks.
And we are kind of out of time, and we are actually having a big company meeting at 2. So I think we will not have the time to wait this out.
Mm-hmm. But that's it. So that's pretty much how it works. So instead of just running another deployment tool, so everything is based on Git and on the repositories for each environment, just like pretty much as Adam was describing on this diagram. So by the way, the draw.io thing was pretty good to watch. So pretty dynamic, way better than boring slides. So please, Adam, do it again.
Okay.
Yeah, this
well,
was
actually,
awesome.
guys, if somebody still has questions that they couldn't ask now or come up with something, we are doing another one at 6 p.m. Right, Teresa?
Yes.
Yeah, so we're doing the same session basically at 6 p.m. But if you would like you can totally join again and ask any questions, or even ask to, like, we can even have more time for this demo maybe that time. So
Yeah,
thank
totally.
you everybody for joining today. Thank you very much, Rafal, for the demo. Thank you, Teresa, for organizing.
No worries. Thank you guys for your time, and please keep track of our events website. We will be organizing more events like this, so make sure you don't miss anything. All right. Have a great day, everyone. Thanks for your time. Bye.
Goodbye.
Thank you. Bye-bye.
No, let's make up some names. But